Hello, Algebra 2, Trig Honors. Welcome. Hope you guys are all well. I feel like you guys would all be very happy to know that I have finished all 3 seasons of On My Block, and now I just started All American last night. So there you have it. That's how my, weeks have been going. So here we are. So we're in our last section of chapter 6. So this is our last one before our test. So the one thing you need for this to kind of help you is your unit circle. So if you don't have your unit circle, grab your unit circle. If you don't want to grab your unit circle, then just flip to the notes where we talked about the 4 points on the unit circle, like the 90, 180, 270. There's that chart. Okay, so the last thing we're going to be doing is graphing sine and cosine. So if we were to actually, like you can graph all of these. All of these you're able to graph. And so we have parent functions. Just like we did before, we had parent functions of a lot of different graphs. And so we're going to be kind of applying what we already know and applying that to new parent functions. So sine, we're going to set up the same way. We have a t-table. And so we have our x and y values. Now our x values are going to be the input. Now our input is going to be in terms of radians. So our x values are in terms of radians, because we could use degrees. We could have like our input be degrees, but we typically, when we're dealing with trigonometry, we deal with more in radians. Now I could use, like going off of my unit circle, I could use all of these radians: 0, pi over 6, pi over 4, pi over 3, pi over 2, yada, 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 yada. Like I could get all of those. The only ones I'm going to use are the ones on the axes. So 0 radians, pi over 2 radians, pi, 3 pi over 2, and 2 pi. So I'm going to start there. So I'm just going to write my x values: 0, pi over 2, pi, 3 pi over 2, and 2 pi. So it really doesn't matter what you use, but those are like the typical ones. Those are the ones that we're going to use. Just like we could use, like we use -2 to 2, and you can really use any x values. This is just the easiest ones that we choose. Okay, so what we do is, remember what's happening is we're plugging in 0 in for x. So it would be the sine of 0. And so the sine of 0, if we go to our unit circle, the sine of 0, remember sine is my y value. So the sine of 0 is 0. Okay, now let's look at pi over 2. So what would be the sine of pi over 2? So the sine of pi over 2 is my y value, is 1. So pi over 2 is 1. Now what I want you guys to try is filling in for sine of pi, sine of 3 pi over 2, and sine of 2 pi. So pause me here and try those, and then come back and see if you got those correct. So you should be coming back. I just can't make those pauses like normal, but one day I guess I'll get used to it. I don't know. It's weird. Okay, so sine of pi, my y value at pi is 0. So it's going to be 0. Sine of 3 pi over 2 is -1. That y value is -1. And then sine of 2 pi is back up to 0, same thing, so it's 0. And then we are going to graph that. So I'm going to label my x-axes with these values. So 0 is going to stay normal. And then pi over 2, pi, 3 pi over 2, and 2 pi. 2 pi. And then these are just going to be normal 1 and -1. So my y values, just in case you're like, well, where did those come from? Those are the outputs when plugging the radian value into sine x. Okay, so then we are going to graph this. So 0, 0 is here. Pi over 2 is at 1. Pi is at 0. 3 pi over 2 is at -1. And 2 pi is at 0. Now, if I wanted to keep going, let's say I wanted to keep finding new points. So the next one after 2 pi is going to be, let's say that's 5 pi over 2. And 5 pi over 2 is back at pi over 2. And the sine of pi over 2 is going to be 1. So we'd go back up to 1. And then the next one would be 3 pi. And 3 pi would be at 180 or pi. And the sine would be 0. So it'd be back to 0. And so hopefully what you're noticing is no matter what, like if I went -pi over 2, -pi over 2 would be here. And that would be at -1. And so it would be here. And so what you're noticing, hopefully, is that this graph is basically, it's like a wave. And it continues this pattern from 0 to 1 to 0 to -1 and back up to 0 over and over and over. And so if we were to actually graph that, if you guys were to graph that on Desmos, which we can do that. So if I were to use Desmos, which let's, you can see what podcast I was listening to. I was listening to Crime Junkie. So that still feels like it's super bright. Maybe that's better. Okay, so if I were to graph that, y equals, I have to find my functions, sine of x. Notice I could keep going forever and ever and ever, and it's still that same like wavelength pattern. So if I when I go back, if I zoom in, now it's hard to tell where this highest point is because it's in radians. But now you can see pi over 2 is at 1. It actually converts it, even though we're not you're not seeing that on the x-axis. It converts it to radians on Desmos because that's how we typically deal with trig functions. Okay, so let's first, before we talk about period, talk about amplitude. So amplitude is basically talking about how high this wavelength goes from the center. So if you think about where is my center, well, my center is the x-axis. And if you're thinking about basically how high up this goes, it goes up 1 unit. and it goes down 1 unit. It goes up 1 unit and it goes down 1 unit. So the amplitude is always going to be, for my parent function, 1. Now, a period. So what a period talks about is like basically how long it takes for this pattern to restart. So you noticed, like when we were graphing, it restarts after a certain point. So it goes from 0 to 1 to 0 to -1 to 0. And then it goes back up to 1 to 0 to -1 to 0. And so the period is basically always for a parent function, 2 pi. So let's kind of label that. So first, this distance from here and to here is the amplitude. I probably should have used a different color, but we're committing. So the height of the wavelength is the amplitude. Now, what's nice is there's a really easy way to help you to find the amplitude without even graphing. And then the period, like I said, the period is basically how long it takes for it to repeat the same pattern. So from 0 to 2 pi is the length of one period. So it goes up, down, and back up. And then it's going to go up, down, and back up, and up, down, and back up. So the length of one period is 2 pi. Okay. So what we're going to do is we are going to now look at cosine. So if you guys do have any questions about the parent function of sine, please, please, please come to office hours. Ask me there. Happy to help you with those. And then let's go to cosine. So cosine, just like we always do with like parent functions, we use the same x values that I used up here. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. So now our y values are going to change, right? Because we're now, instead of plugging those radians into sine, we're plugging in those radians in for cosine. So what I want you guys to do is pause me here, and I want you guys to try and get your y values on your own. So try and get those y values just like we did up here using the unit circle, and get those on your own. So pause me here and then come back and check your work. So hopefully you paused me and you come back and we're just checking. So at 0, cosine is 1. At pi over 2, cosine, the x value is 0. At pi, the cosine, the x value is -1. At 3 pi over 2, the x value is 0. And then 2 pi, we're back up to 1. And so again, I'm going to label my x-axis, pi over 2, pi, 3 pi over 2, and 2 pi. And then 1 and -1. So 0 is at 1. Pi over 2 is at 0. Pi is at -1. 3 pi over 2 is at 0. And 2 pi is at 1. So if we now go back and also look, okay, well, what's 5 pi over 2 going to be? 5 pi over 2 is going to be at pi over 2. Those are coterminal angles. It would be at 0. If I were to look at, well, what about negative pi over 2? Negative pi over 2 would be here, and that would be at 0. So this pattern looks like this. Really similar to sine. So again, if I were to graph that using Desmos, we could go in and do the same thing that I did here. So y equals cosine x, and see that it's the same thing. It continues on in that same pattern over and over and over. And we can look like, where are these points? Well, pi is at -1, which we have. 0 is at 1. Pi over 2 is at 0. So all of those give me my points there. Okay, so then let's talk about the period and the amplitude. So I want you to think about, what do you think the amplitude, let's start with amplitude. So what do you think the height is from the center? Remember, the center right now is at 0. And so what's the highest that it's going up and down? And if you are saying 1, you're correct, right? Because the height is this distance. It goes 1 unit and 1 unit. Those are both the amplitude. And then what do we think the period is? So when does the pattern restart? If we look at 0, where does that restart? Well, it goes, it's at 1, 0, -1, 0, 1. 0, -1, 0, 1. So the period is actually the same as sine. It's 2 pi. And so it's from 0 to 2 pi is the length of one period. Now, obviously, all of these can change when we apply our transformations, which we are going to do. So all of these are going to change, but it's just for right now, seeing what the normal is for my parent functions. And then we're going to apply our transformations, what we already know, and use that to help us. So let's kind of do a little refresher of transformations and everything that you guys have learned about transformations last semester. Okay, so let's start with like the one that we probably know like is the easiest, which is D. So is D within the function or is it outside the function? And remember, this can be replaced. So like this could be part of any function. So I could have put cosine here, but I just put sine here. So is D within the function or is it outside the function? And if you're saying outside, you would be correct. So when it's outside the function, is that a change to an x or is that a change to a y? And it would be a change to the y values. And so remember, when it's a change to the y values, that's like a y values is up and down. And that's all it's doing. So it would be moving the graph up or down. So moves graph up or down. Okay. So the other one that you are pretty familiar with is C. So remember C, with C, is that within the function or is that outside the function? And if you're thinking it's within, you are correct. And so if it's within the function, is that going to be a change to x or a change to y? So that would be a change to x. And when it's a change to the x value, the x is like here and here, right? So change to the x value shifts it either left or right. So shifts graph left or right. Okay, now we have two more, and we haven't really dealt with B that much, but I'm gonna come to that last. So I'm gonna go to A, because we've seen A. And so is A within the function or is it outside the function? And if you're saying it's outside, you're correct. And so is when it's outside, is it a change to X or Y? And you should be thinking it's a change to Y. And remember with with A, remember I referenced those exercise bands. And so it's like when we pull up on the exercise band, it stretches it. And when we let go of the exercise band, it's like a compression. It's like getting like wider. And that's exactly what A is. A is stretching up the graph or compressing it. So it causes a vertical stretch or compression. So causes a vertical stretch or compression. Now, remember how I said there's a really easy way to find the amplitude. The amplitude is the height. And if that's stretched or if that's compressed, that's what's going to change, right? And so if we look at the A, the absolute value of A will always tell me the amplitude. So that's huge. So I can look at like this function below and I can tell you that just by looking at it, the amplitude is going to be 3. Okay, so last part, let's look at B. So B, is that within the function or is that outside the function? And that is within the function. And so if it's within the function, is that a change to the X or a change to the Y? And that should be a change to the X. Squeeze that in here. So that's going to be a change to X values. Now, what this does is it actually causes, very similar to this one, it's like an accordion. It causes a horizontal stretch or a horizontal compression. So it's like either pulling it out and stretching it or pushing it together and compressing it. So it causes a horizontal stretch or compression. Okay, and what that does, if you think about it, if we're pushing this together or stretching it out, what that's actually changing is the length of the period. And so B is going to be, B is a change to the length of the period. So change to the length of the period. And there's actually a formula to finding the period. And so you can use this. So the period is going to be the original period, which in the only ones that we're doing, because we're not going to deal with tangent, you will in pre-calc, is just taking the original period, 2 pi, and dividing it by b. And that is that. Okay. The last thing, let's kind of reiterate here. When it's a change to the x value, do you do the same operation or the opposite operation? So when it's with n, do you do the same operation? Would I be multiplying by b or would I be dividing by b? Would I be subtracting by c or adding by c? And if you're saying the opposite operation, you are correct. And then change to y. If x value is the opposite operation, change to y is the same operation. Okay, so that would be that for our very quick review of transformations. If you guys need more review, we did a ton of those last semester, so you guys should have them in your notes, but we're going to review it today when we do the practice problems, so don't worry about it. Okay, so let's look at our first one. So our first one says graph each function using transformations. So we always start with my parent function. My parent function I look at, and it's going to be cosine, right? So we're going to use that parent function table first. So my x values don't change. 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then my y values, we could use these, or you can just always look at the unit circle. And remember, for cosine, it's the x value on the unit circle. Whereas sine is the y value on, you can't see that, y value on the unit circle. Sorry, I went off on, side tangent there. Okay, so our y values would be 1, 0, -1, 0, and 1. So we apply our transformations just like we normally would apply our transformations like before. So I look at my two numbers that are there and I see, okay, we have 3. 3 is going to be a change to the x, or is it going to be a change to the y? If you're saying change to y, you are correct. And then 2. So is 2 going to be a change to the x or a change to the y? If you're saying change to x, you would be correct. And now we can apply those. So when it's a change to the x, we do the opposite operation. So what's happening here is it's 2 times x. So what we're going to do is do x divided by 2 for all of our x values. And then this is 3 times cosine. And so with y values, we do the same operation. So we're going to do 3y. So that one's easier, right? All of my y values, I'm going to be multiplying by 3. That doesn't take much thought there. But now all of my x values, we're going to divide by 2. So 0 divided by 2, I'm just going to write all of these. Pi over 2 divided by 2, pi divided by 2, 3 pi over 2 divided by 2, and 2 pi divided by 2. Now, some of these, you can do in your head, right? some of these aren't that hard. So 0 divided by 2 is 0. But pi over 2 divided by 2, that's like a little bit weirder. So if we think about that, just like logically thinking, pi over 2 divided by 2. So do you guys agree that that is the same as that? I'm just dividing it. I'm writing it instead as a fraction with the division symbol. So if we were to do that, we would multiply and flip the second fraction. And so we would get pi over 4, which is exactly what that is. You can also like plug it into your calculator. Ignore the pi for now and just do like 1/2 divided, I didn't put my extra parentheses, divided by 2. And, we know 0.25 is 1/4. However you want to think about it, or we can just think about it in our heads. Pi over 2, that's pi over 2. 3 pi over 2 divided by 2 is going to get me 3 pi over 4. The 2 and 2 are both going to stay in the denominator to multiply together to get me 4. And then 2 pi over 2 simplifies to be pi. And then 3, 0, -3, 0, 3. And then we can graph. So I don't have 3, so I'm just going to put those in, 3 and -3. And then I'll plot my points. Pi over 4, pi over 2, 3 pi over 4, and pi. And I'm going to graph my curve. So 0 is at 3, pi over 4 is at 0, -3, 3 pi over 4, and then pi is at 3. Now, I don't want you guys to draw this as a parabola, like with it going like that, because we know it follows the same pattern. It's going to come back down after these. So the way that you should be drawing it is exactly like that, with that pattern showing that it's not going to go up after that. Okay, so then my period, the period is, remember, always looking at the A value. The amplitude is always looking at the A value. Amplitude A, and A. So my amplitude here is 3. And my period is looking at the B value and taking that and taking my original period of 2 pi and dividing it by B. So 2 pi divided by 2 is pi, which if we look here, when does it restart is at pi. And that would be my answer. And that would be the end of number 1. Okay, so I'm going to turn to the next 2 problems. But before I do that, what I want you guys to do is I want you guys to think first, what's the amplitude of each of these, and then what's the period of each of these. So pause me here and think about those on your own. So what's the amplitude? What's the period? Okay, so if you should be coming back from your pause and thinking you should already know the amplitude. So first, the amplitude of 2, remember, is looking at this A value. And so the amplitude here is 2. And the amplitude will always be positive because the distance is always positive. And then for 3, the amplitude, if we're looking, we look at this -1. But remember, the amplitude is always the absolute value of A. So the amplitude is still 1. Okay, so then let's look at what our period will be. Now we have to think, is there a B term here? Is there something that's being multiplied by X? And there isn't, so my period is going to stay the same as 2 pi. And then we look at 3 and think, what's being multiplied by X? And that's pi. So what we're going to do for that period is going to be 2 pi divided by pi, which gets me 2. And that is the answers for those parts. Okay, so if you guys feel comfortable with these, like graphing these, great. If you guys want to go through, let's go through this, then let's go through this. But if you are feeling good with like going forward on your own, try it on your own right now. If not, then I'm going to have you guys try 3. Okay, so my parent function, when we look at the trig function and we see sine, so my parent function is sine x. And so we start with that table. My x values are always the same. I don't even have to think about those. And then my y values are looking at the parent function. So it's going to be 0, 1, 0, -1, and 0. Okay, so from there we can apply our transformations. We already know one of them, 2. Now is 2 going to be a change to the x or a change to the y? And it's a change to the y. And then that minus pi. So that minus pi, is that going to be a change to the x or is that going to be a change to the y? And it's going to be a change to the x. Okay, so what we're going to do is we're going to apply those transformations into our middle table. So all of my x values, what we're going to do, are we going to do the same operation or the opposite operation? And we're going to do the opposite. This is a minus pi, so we're going to add pi to everything. And then my 2 is changed to y. So for y values, do we do the same operation or the opposite operation? And it's the same operation. So we'd multiply all of my y values by 2. And so we get our final answer. Now this one's easy, right? 2 times 0 is 0, 2, 0, -2, 0. But this is a little bit more challenging. So 0 plus pi is easy, that's pi. But pi over 2 plus pi, now you can do it 2 ways. You can like do it, by hand, pi over 2 plus pi over 1, get a common denominator. And then we'd add that and get 3 pi over 2. You can do it in your calculator too, so ignore the pi and do like, that would be 1/2 plus 1, and then 3/2, and then throw the pi in at top, so 3 pi over 2, which is what we got. So we're going to do that. Pi plus pi is 2 pi. 3 pi over 2 plus pi is 5 pi over 2, and 2 pi plus pi is 3 pi. Now with this one, we can't just start from 0 to pi, because 0 to pi is not the same distance as pi to 3 pi over 2. So that would be like putting this would be 0 to 5, and then 5, and then put 6, 7, 8, 9, 10. That wouldn't make sense. That spatial reasoning wouldn't be there. So what we have to do is we have to actually write everything that's before it. So before pi is 0, which is here, and then pi over 2. And then we can write pi, 3 pi over 2, 2 pi, 5 pi over 2, and I'm going to add in 3 pi. And then 2 and negative 2. And then I can graph that. So at pi, we're at 0. 3 pi over 2, we're at 2. 2 pi, we're at 0. 5 pi over 2, we're at negative 2. And then 3 pi, we're at. And so again, we want to show that we understand the pattern. We know it's going to keep going down there. Remember, the pattern is going to keep going in this like cyclical way. Okay, so that was 2. Now what I want you guys to do is pause me here. There are 3 transformations for 3. I want you to start by just setting up your parent function, add in the transformations, and get your third table. So just try that first on your own and then come back and make sure you did it correctly. So you should be coming back and seeing, okay, did I first start with my parent function correctly? And so remember, your parent function is cosine x. So with the magic of video, the parent function table has appeared, and there it is. So that's what you should have started with. And then you have your 3 transformations. So the negative 1 is on the outside. It's a change to the y values. That pi is on the inside. It's going to be a change to x values. And then that minus 1 is on the outside. It's going to be a change to the y values. And so we're going to apply those transformations. So all of my x values, we do the opposite operation. So if it's pi times x, I'm going to divide all of my x values by pi. And then we have 2 things that are happening to y. So I'm going to multiply all of my y values by negative 1. And then I'm also going to subtract 1 from y. Because remember, we do the same operation for y. So it'd be 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then we're going to divide everything by pi. And then here, we're going to take all of our y values. We're going to start by multiplying everything by negative 1. We multiply before we add our subtract. And then we're going to subtract 1. And now I can get my final table. 0 divided by pi is 0. Pi over 2 divided by pi. Well, the pi's just cancel, and I'm left with 1/2. Pi divided by pi is 1. 3 pi over 2 divided by pi. The pi's cancel. I'm left with 3 over 2. And 2 pi over pi is 2. Okay, now negative 1 times 1 is negative 1, and negative 1 minus 1 is negative 2. Negative 1 times 0 is 0, minus 1 is minus 1. Negative 1 times negative 1 is 1, 1 minus 1 is 0. 0 minus 1, and negative 1 minus 1. And so I'm going to label negative 1, negative 2. This one we don't have to worry because the distance from 0 to 1/2 is the same as the distance from 1/2 to 1. 3/2 and 2. And then I can plot my points. 0 is at negative 2. 1/2 is at negative 1. 1 is at 0. 3 halves is at -1, and 2 is at -2. Now remember, we know this is going to be cyclical, so we know that it's not just going to be this like downwards facing parabola. It's actually going to be like this. And that's your answer. Now, amplitude is still 1 here. And the reason is because now the center is at -1, and the distance from -1 to 0 is 1, and the distance from -1 to -2 is 1. So that's it. I figured I would let you guys see. So my final thing last night, I finally finished my next puzzle. And so I'll show you the final product. So here's the final product. And if we look really closely at the final product, we notice this sad spot. And I have looked everywhere for that. And I don't know where it is. I've decided it didn't come in the puzzle. And I'm very sad about it, but that's okay. It's still a cool puzzle. So, yay for that. On to the next one. Okay, that's it for notes. That's it for chapter 6. So the next video is going to be your study guide. So there you have it. I hope you guys had a great enrichment week. Had a nice break. Did something, I don't know, different. I don't know. Who knows? We can't do anything really that different. So, but I hope you guys have a great rest of your day, and I will talk to you guys later.